Okay, I think I figured out whatever the problem was with the encoder. Hopefully a couple people will trickle in there. Hello, Anna. Sorry about the technical difficulties, folks. Took me a second to get online here. Or maybe because this is over break, we're gonna get nobody watching. 0 watching. Feels bad. Wonder if people are watching the wrong one. Oh, no, Jana just commented. There's somebody actually here. There's somebody actually here. Oh. All right. This will be the highlight of my break. Feels bad, Dan. Than normal because it is over break, and goodness knows I didn't want to be working today, but you know, whatever. What I wanted to start off with was, as per normal, the quiz, and then I'm going to jump into the free response worksheet, and then I got some questions online. So, starting off on our quiz, what a majority of people did wrong, at least from what I graded, was not distribute the x into both of these terms. You didn't have to do this, but you were way less likely to make a mistake if you did this. So if you distribute, you get 3x cubed plus 15x, and then this is an easy natural log derivative problem. It's just going to be 9x squared plus 15 du over u 3x cubed plus 15x. And booyah, that's that answer. Now, if you left it as x times 3x squared plus 15, you could have still gotten this right by getting 1 over x times 3x squared plus 15 times, and now you have a product rule for your chain rule part. And so derivative of the first times the second plus the first times the derivative of the second, and surprise, these are exactly the same because this is 6x squared plus 3x squared, which is 9x squared. All right, so for the natural log integral problem here, what a majority of people did wrong here was not use u substitution or account for the u substitution. If you make u 5x plus, 13. Yeah, 5x plus 13. Then when you make du, it's 5 dx. And if we write our integral we only have 4 dx's in. 4 dx over 5x plus 13. Now, a lot of people are like, there's no dx in the problem, but that's because how I asked the problem, I didn't need to put a dx. I said that I had a derivative, and I'm like, find the integral. But I didn't set up the integral problem. And so there's no problem that there's no dx there. All right, so now we just substitute in. Whoops, that's a dx. If you solve for dx here, you don't have to worry about any fractions deals. So du over 5 equals dx. I substitute back in, I get 4 times du over 5 over u, because 5x plus 13 is u. So we get 4/5 times du over u, and so this was just a natural log of u, so it was 4/5 natural log of u plus c. And we need absolute value around the u, and then we need to plug in what u is, so 4/5 natural log of absolute value of 5x plus 13 plus c. Now, a crud ton of the people who got this question right, and who I gave 5s to, didn't remember the absolute values, but remember the absolute values. I dinged you on 29 if you forgot absolute values there as well, but I was kind of kind for the rest of this. All right, next question. Let's pop back since I'm having a hard time with questions. Caden Lee, hi, I'm some random person. Oh, that's so nice of you. All right, so we're doing logarithmic differentiation here. So we're natural logging both sides from the get-go. We get natural log of y equals natural log of x squared plus 1 to the 2x minus 1, or plus 1. But then we always pull our power down in front of the natural log. So we get natural log of y equals 2x plus 1, in parentheses, times the natural log of x squared plus 1. And now we can take the derivative. We just do a little bit of product rule. Not on this side. This side stays easy. But on the other side, we have a derivative of the first times the second plus the first times the derivative of the second, which is 2x over x squared plus 1. A lot of people forgot the chain rule part for du over u, the 2x over x squared plus 1. That was a tad sad. And then lastly, all we do in these questions is multiply the y to the other side. So y is x squared plus 1 to the 2x plus 1. And we multiply by parentheses all this junk. So 2 natural log of x squared plus 1. And if you were super special, you could put the 2 in the power, but you don't need to. Plus 4x squared plus 2x over x squared plus 1. That's a very acceptable answer. Yeah. That's logarithmic differentiation. And lastly, and I know some of you are like, this isn't my version of the quiz, but we'll go and look at the other one in a second. It's real similar. Like really, really similar. All right. I think this was the kinder of the two long division problems. But what a lot of people did, and what is smart to do, is to divide the 2 out from the get-go, rewriting this as the integral of x cubed minus 2x squared plus x minus 2 over x minus 2. Yeah. Because this makes the division really easy. We're dividing 2 into 2, -4, 2, and -4. So I do a synthetic because I'm lazy, and synthetic is really fast. And yeah, this was the one that ended up really nice. Sweet. Oh, what did I... Oh, I did a bad. I'm sorry, folks. I did a bad. This was all wrong. I divided into the original term, which a lot of you did, and you got 2x squared plus 2, and then you integrated this, but that's not correct. So what I was just doing was actually the incorrect way a lot of people did, which is they found the factor on the bottom here too, but forgot to divide by 2 at the end. So if we actually do this and plug in 1, -2, 1, and -2, it works out the same way. It works out in our favor. 0, 1, 2, 0. And we get x squared plus 1. And if you think about it, if we do it the 2 separate ways and we get a different answer, it means it's not consistent between those 2 ways. And you need to account for the fact that this is 2 times the factor of 2 on the bottom, the root of 2 on the bottom. So 2 times x minus 2. And you need to divide by that 2 after you've finished dividing in. And so that's a majority of what people did wrong in that this section specifically, was to leave that factor in and integrate this thing down here, which is not what you want to do. So we integrate this guy, and you just get x cubed over 3 plus x dx. Whoops, plus c. I'm a little rusty on the calculus here. I'm having a hard time getting comments to show up on my iPad. Oh, there they are. Let's see this. Whoa, I'm here now. I'm in Briarwood Elementary. Aww. Alright, so looking at the other quiz, just to talk about some notable differences between them. I'm not going to do as in-depth on the questions. Here, same way, in this opening part, you want to distribute. It just makes life easier, but you could have gotten it right as long as you did the product rule when you did the chain rule for the natural log. For 27.2, you should have gotten a 3/2 or a 1.5 times the natural log of 2x plus 13. For the same reason, whoops, absolute values. For the same reason that we got a 4/5 when we did the other version, you have to do u substitution, u equals 2x plus 13, du equals 2 dx. And so dx equals du over 2, and that's where our 1/2 comes from that ends up in our answer here. So a lot of people didn't do that u substitution. Pretty much everyone who did the u substitution got this question right, but people who are not doing u substitution are still getting things wrong there. I did want to point out down here in this one didn't divide in as nicely. You could also divide by 3 in all the terms here, so the niceness of the numbers was similar. So if you divide everything by 3, you get this. You can divide the 2 in, but it's 1, -3, 5, and -1, so we do get a term left over. We get a, what do we get? 3, 6, so we get a 5 left over. And I just wanted to go through exactly what you get as an answer for this, because a lot of people seem confused as to what to do when you finish this step and go on to the integral part. And this one was harder than the other version of the quiz. So we get to the integral, and we get x squared minus x plus 3 plus 5 over what you divided by, which is x minus 2. Once you get to this point, it's just integration. We get x cubed over 3 minus x squared over 2 plus 3x plus 5 natural log of x minus 2 plus c. And you needed the absolute value here. A ton of people forgot it. I dinged everybody in this section because we aren't retaking this one. So you have more opportunity to remedy it before, you know, you take the test or whatever. Let's see how we're doing. Seems good so far. No questions in the chat. That's the quiz. If anybody has any questions on the quiz, feel free to holler at me. I'll try to pay attention to your questions. I figured out how to get comments on my iPad here, so life is good on that front. And I wanted to jump into the free response questions now, because those are the fun ones. Alright, so these questions, I can guarantee you, prepare you well for the free response question on the test. I hand wrote both of the free response questions for the test, so they are new creations of mine. So you can't actually look up an AP question that's like them, but I tried to kind of meld together parts of all the different questions here. So if you know all these skills in this section on these AP questions, you should be good to go. Starting off with the easiest question, find the acceleration at time t equals 4. This guy started off with just a nice little derivative question, as I struggle to get into draw mode here. Oh, whatever, we'll have a nice border. We take the derivative of natural log of t squared minus 3t plus 3, and we get 2t minus 3 over t squared minus 3t plus 3. And then you just plug in 4, and you get 5 over 16 minus 12 is 4 plus 3 is 7. I assume people are going to correct me if I get these wrong. Hopefully. The chat seems incredibly quiet, or I'm not updating. Really? Next question. Find all the times t in the open interval where the particle changes direction. What we're looking for is where v is 0. That's where natural log equals 1. Oh, Johanna's here, so we're good. All right, sick. So what I want is where this natural log's inside is equal to 1, because that's where v is 0. Because where my velocity is 0 is where I change direction, go from negative to positive or from positive to negative. So I solve for where t squared minus 3t plus 3 equals 1. And it turns out, if you subtract the 1 over, you get t squared minus 3t plus 2 equals 0. So you get t minus 2 and t minus 1. That factors like really easily. So 1 and 2 are the 2 points on which it changes direction. And then we're supposed to figure out where it's traveling to the left. And so we set up our little table like the first derivative test sort of thing. And we just kind of test the value in between and test values on the edges. And see what we get. And if we plug 0 in, we just get positive 3. So that's increasing, so that's no good. If we plug 1.5 in, we get negative 0.5 times 0.5, negative 0.25. Yeah, that's going left. Because down here, negative velocity is to the left. And if we plug 3 in, we're positive. We're 1 times 3, so we're back to 3. And we're going up. So it's between 1 and 2 where the particle is traveling to the left. So left here. I guess I could do that nicer, like maybe do the x notation. Left. For x is between 1 and 2. I don't know, whatever, man. Alright. Find the position of the particle at time t equals 2. I'm not going to whip out the calculator here, but I am going to show the integral I used to get this. And yeah, I use an integral for this. So I'm going to wipe out all the garbage over on this side. Let's get rid of that stuff. Erase. Okay, so to find the position at t equals 2, well, we know the position at t equals 0. So we're going to start from there. We start at 8, and we're going to add how it changes from 0 to 2, which is the integral from 0 to 2. And we're integrating velocity to get to position, so I'm just going to plug in the velocity equation. dt, and booyah. If I integrate velocity, it's going to tell me how my position changes from my starting place of being 8 to the right. And this ends up being 3 point something or something like that. I don't remember exactly. Something like that. Alright, next. Find the average speed of the particle from 0 to 2. This is stupidly similar to what we just did, because we use the exact same integral. Because to find average speed, what we're going to do is we're going to integrate, well, it's a little different. We're going to integrate the absolute value of the velocity from 0 to 2. Because speed is the absolute value of velocity. And so we're just going to plug in the velocity, which is natural log of t squared minus 3t plus 3. Ugh. Put that in absolute value and plug and chug this in your calculator. You have no idea how to integrate natural log, and you don't need to do it to do this problem. You just type this crap into your calculator. The integral of our velocity equation in absolute values. That's what these dudes are. dt. And that's that question. And we quiet. Jake's here. Hi, Jake. And let's go on to the next one. I noticed a lot of the questions I got were from the later ones, notably the last one. Yeah, most of my questions were from the last one that I got online. Okay, come on. Oh, whoops. All right. This one should be really, really similar to calculators cheated. No, it's not. Well, you don't get it on the test, but I made the questions kind of nice, so you don't need it. Kind of. And I'm not going to make you simplify answers. I think one of the answers ends up being a little janky to one of the questions, but you can just leave it as some massive fraction-y thing. And that's cool. Okay, so using appropriate units, explain the meaning of the absolute value of velocity. Well, funny enough, I feel like we just did this, because this was the exact thing we did for part D in question 3. Is we did this to find the average speed. So what this is average speed of car from t equals 0 to t equals t equals 30 to t equals 60 in, and the units are feet per second. That would be a good way to describe that. Now you're supposed to approximate it using trapezoidal sums. So we're looking at this stuff in the table, the 30 to 60 garbage. And we are approximating the velocity. So we're going to find the average of these two, the average of these two, and the average of these two to find the heights of those trapezoids. -12, -5, and 5. And then I just multiply by the widths, so 5 times -12. Whoops, that ain't no -12, that's a positive 12, because I'm doing the absolute value. Plus 5 times, not -5, that's a positive 5. Plus 5 times 5, and we get that the average speed over this interval is this stuff, all this area here, 50 plus 60, 110, divided by its width. And so its average speed's like something completely garbage. Why am I dividing by the width? Oh my god, I'm a disaster. What am I doing? I'm too tired for this. Let's look at the chat and see people making fun of me. This is the time to make fun of me, as I'm getting all frazzled here. So I'm just approximating the integral. Alright, that's the displacement change. My displacement change is 110 feet. Feeling good. Which means oh my god, I'm a bit of a disaster right now. I apologize, folks. I screwed up that first question. So let's start from the top. It's okay, we're all a little tired. Isn't 6a supposed to be the distance? Yeah, it is. It is the distance traveled. I figure out it is the distance traveled, but the integral of that from 30 to 60 is the average speed. Oops. Timothy gives me an F. Feels bad. Alright. So, let's move forward. To summarize, this was a distance traveled of a car in feet, not in feet per second, from 30 to 60, because we're not dividing by the width, so we're not finding the average speed. Whoops. And then we approximate the distance traveled by plugging in the positive speeds, because velocity can be negative, but speed can be positive. And we add those up, and we get 110. Alright, I'm feeling a little less crappy here. So now we need to say, what is the integral of the acceleration? Well, that's the acceleration is the change in velocity. So if we integrate acceleration, we get velocity. So that's like the change in velocity. The integral of acceleration tells us the change in velocity of the car. So it's the change in velocity of car. Of care? Yeah, totally. From t equals 0 to t equals 30. And velocity is measured in feet per second. I actually get this one to be velocity because it's the integral of acceleration. Okay. Now for the fun part, and this is the part I'm actually prepared for. Andrew Chu says, "Can you start over?" I did start over. Starting over in 6. What this integral says is we are integrating the speed from 30 to 60. That gives us distance traveled. If we integrated not the absolute value of v of t and integrated the velocity instead, we would get the displacement change. But we aren't curious about that. We're curious about the distance traveled. Then we went with trapezoidal sums, and we added together the width of all those things, which I completely did garbagely because I forgot that these were different widths. Disaster strikes again. This is 60 plus 75 plus 50. That's 110 plus 75. That's 185. Feet. Does this seem right, folks? Did I start over and get the question right? Then in B, what I'm doing is integrating acceleration, which gives me velocity, and because I'm integrating from 0 to 30, I'm getting the change in velocity. That's what the acceleration gives me, is the change in velocity, the increase in velocity, from 0 to 30 in feet per second. All right, Johanna says I'm right, I think. So yeah, this seems right. I actually multiplied by their widths, like this one's 10 wide, and this one's 15 wide, and this one's 5 wide, and I actually took that into account. Seems good. Should have looked at these a little more. All right, for C, this is where things get crazy, so let's kill all of this. Whoops, that's not my eraser. So I can actually talk about C and D here. So for C it says, can the velocity ever be -5? Or does it have to be -5? And so we look at the question and we're like, is this thing continuous? And we're like, heck yes. This is a way of saying that the car's position is twice differentiable because it tells us the acceleration and the velocity are both continuous functions. So if v is, whoops, I still have crap in the way here. If v is continuous, then IVT says it must be -5 at, and we look up at our table and we're like somewhere on this interval because it goes from -10 to 0. So we're like on the interval 35 to 50. So instead of add, I'm going to change that to, whoa, that's a ruler. On the interval 35 to 50. So, and then you could add like where it goes from -10 to 0. And that's a good enough answer for that one. So this was an intermediate value theorem question. D is where it gets hairier, and it's kind of like that question that 3rd and 4th period had on the final, the very last one. For D, it's, because the IVT said, like I did it here, I said it was continuous, and so IVT depends on continuity, and so I say it has to be -5 on the interval specified, so I gave the specific interval, and I said where it goes from -10 to 0, so I said that -5 is kind of in between those. So I gave the interval, I gave the reason why, I said it was IVT, and I said it was continuous, which are all the things required to do an IVT proof. Is interval, the justification, like the values, and the fact that the thing is continuous. So those are my descriptions for that. I'm confused. This is written on my screen but not showing up. Am I dropping frames again? Let's go look. No, I'm not dropping frames. Alright, I'm super confused. Maybe my YouTube video just crashed. Is my stream alright? Yeah, I just paused it. All right, sick. Okay, so for D, this one's asking, does the acceleration after... yeah, I got it, Andrew. Chill. For D, acceleration, does it have to be 0? And if we look at the accelerations, we're like, heck no! It never goes to negatives and back to positives, but that's not good enough. That's kind of the lazy way around it. We look at that, and we're like, okay, no easy money here. But what we're going to get hooked up with here is... Why is my stream still? You're currently not dropping frames, but I'm experiencing decent amounts of buffering. This is annoying me. When I started the stream, I was dropping so many frames, but I'm getting pretty good upload speeds. I'm getting like 3 megabytes a second right now. Have the stream issues been bad the whole time? Does the lazy way get you a point on the AP test? It actually gets you 0 here because it's wrong. So, what the heck? Why is this... I'm getting pretty tilted here. Whatever. So, looking at D. The reason why D has an answer and it's not that there is nothing there is because we have to look at the velocity. So what we're doing is mean value theorem. So we're saying, hey, the velocity at 0 is the same as the velocity at 25. Oh, and yeah, I can see my stuff actually finally updating. Holy smokes. I don't know what's going on with my internet tonight. I apologize, folks. But if you look at when t equals 0 and t equals 25, the velocity is negative 20 at both of those. So if I do the mean value theorem, like the mean value, the average rate of change, negative 20 minus a negative 20 all over 25 minus 0, I get that the average slope of the velocity is 0 on the interval 0 to 25. So the mean value theorem guarantees on this interval there is one point where the acceleration is 0. Oh, I know what's going on. I'm way behind my live stream. I need to click the live button. Alright, sick. So, yeah. This is the big idea, is that because you can see that the velocities are the same at 0 and at 25, you can guarantee that in between those two, there needs to be a critical point, a point where the velocity is 0. And you know that because velocity is differentiable. Velocity is differentiable. And so differentiable. So the mean value theorem guarantees 1 point. How many theorems are there? For questions like this, there's the intermediate value theorem and the mean value theorem. There's also the average value theorem, but that one's pretty easy. That's the integral divided by the width equals the average value. Most of these are like really intuitive, these things, but they save you a ton of time if you know them, and you can actually use them to describe what you need to. Alright, so I want to look at 6 now. Feel free to ask me any questions about the ones I've already covered. How can I make this look better? Can I drag this? Whatever. So for 6, we're given in the first one that we're supposed to find the second derivative of this thing and the first derivative of this thing. So if I take the derivative of g of x as it's given, I get that g prime of x is equal to a e to the ax plus f prime of x. That's my first derivative. Okay, I'll find g of 0, or g prime of 0 here. I just plug in 0. I get a times e to the 0, sick, that's 1, so just a here, plus f prime of 0, which is negative 4. So g prime of 0 equals a minus 4. Sick. Done with that one. Next one, g double prime. So I got to take the derivative of g prime. I chain rule down another a in the exponent. So I get an a squared e to the ax plus the derivative of f prime is f double prime. And here's my g double prime equation. Now I just plug in f double prime of 0 is 3. I plug in 0 for x. This becomes 1 again, so I get a squared plus 3, and I've solved the first part of the question. That's it. So some people ask where the a squared came from. It comes from the fact that I'm doing two derivatives and chain ruling down the a twice. Because both times the exponential ends up being equal to 1 because I plug a 0 in for its power. And yeah, that's it. When it says show all the work for your answers, it's because they gave you a point for actually solving for the derivative and writing it correctly. So I'm going to like circle all of the things or box all the things that gave you points. This thing was worth a lot of points, like 4. All of those derivatives were worth points. Okay, for the second part of this, we're just finding a tangent line. I like this question because it's like hilarious mix of review and stuff. Do B again. Which B, bro? I'm gonna do B in 6 right now. Okay, so I'm gonna do this above. I'm gonna clear out the stuff, and for 6B, h prime of x is my derivative. So h prime of x equals, I got to do some product rule here. So negative sine of x, f of x, plus cosine of x. Whoops. I forgot the kx in there. I'm going to start from scratch. So h prime of x is equal to negative sine kx times k times f of x. Plus the first thing times the derivative of the second, and this one works out really nicely. It's just an f prime of x. Alright, sick. Now I just plug in all the stuff I know. I get to plug in 0 because I'm trying to find the slope at 0 to find the tangent line. Sine of 0 is 0, so this entire term dies. I'm pretty happy about that. Cosine of 0 is 1, so that becomes 1, and f prime of 0 is negative 4, and so this is negative 4 h prime of x, so that's the slope of my line. Now I just need to find h of 0, because I need to find what the function was originally equal to find a point to put my line in point slope or whatever. So I just plug in 0 here. H of 0 equals 1, cosine of 0 is 1, times f of 0, which is 2, and I get this thing goes through 0, 2, and so I'm really good about that. Andrew, can you clarify which B you wanted, or if I just did it? I'm gonna hope for the best here. All right. So where I wanted to go next was some questions that people quiz questions here. Hearthstone or we walk. Okay. Go back and look at that real quick. Where do I got it? Here. Chapter 5 review. This one. Andrew, I just took a derivative here. So, all I did in this bottom one, whoops, that's not the right thing. All I did in this bottom one was plug in 0, get h of 0 equals 1 times 2, because that's what f of 0 is. So I didn't even take a derivative for this. I just figured out this thing goes through 0, too. Then I figured out its slope by just doing the product rule. So I did the derivative of the first times the second, so negative sine kx times k times f of x, so that's a prime b. And then I need to do a b prime, and that's plus cosine kx times f prime of x. And then once you're here, you just plug in stuff and you get what the value is. We get kind of hooked up in that sine of 0 is 0, and we get just 0 plus negative 4, cosine of 0 is 1, f prime of 0 is negative 4, and we build our equation from that, y equals negative 4x plus 2. So very, very family friendly. Oh, it's a warm-up question. Never mind. Yeah, kind of. When is the test, says Andrew Ha. The test is Wednesday, which is a little bit of a bummer because we're going to miss the cheerleaders and basketball players because apparently they're doing state or something, but there's no winning this time of year with tests. Somebody's going to be missing for everything. So I wanted to kind of run through some questions here. It looks like I need to center the screen a little bit. Okay, looks good. These are kind of some questions I got from people, like, can you just do some more exponential derivatives, integrals, some more log derivatives, integrals, and I kind of put together a worksheety thing. Wait, why is Timothy freaking out? I don't understand, man. So I just kind of wanted to walk through some of these. These are kind of my rewriting of some quizzes that you're going to take very soon. Like Friday. Like exponential derivatives and that sort of thing. So the first one, whenever we do one of these derivatives, we get 2 to the natural log of x plus x squared minus 3. We always rewrite the exponential. If you're not rewriting the exponential when you're doing any exponential problem, you're not doing the exponential problem correctly. So always, always, always. Then what we're doing is we're taking care of the chain rule. So 1 over x plus 2x, that's the derivative of natural log of x plus x squared minus 3. And lastly, we're multiplying by the natural log of the base, so we get a natural log of 2, and booyah, that's my answer. So for derivatives, we're just multiplying by the chain rule, multiplying by the natural log of the base, and we're done with exponentials of different base. In my second example here, I actually went to bases of e's, and there's a couple steps here. Starting off, I split to two integrals, cosine of x e to the sine x plus 1 dx, plus the integral of e to the x dx. The reason I did this is because now I can do u sub over on this side without corrupting my other side. We had a warm-up question that was kind of like this, where a lot of people made u equal to sine x plus 1, and then they messed up this part, the right part of this. So if you separate these to two separate integrals, you can do u sub in one and do easy mode in the other. If I take the derivative of this u that I made, which I use the power because u is really, really often the power in exponential problems, like really, really a lot. And it works out here because I have cosine x dx in my integral. So I have exactly du. So what I am integrating is e to the u du in my left integral, and e to the x dx in my right integral. And when I do this, I just get e to the u plus e to the x plus c. And then I just substitute what u is back in, e to the sine x plus 1 plus e to the x plus c. And we good. So Why is it plus the integral of e to the x and not minus like the original integral? Because I'm a dingus. Let's change that to a negative sign. There we go. Now it's fixed. Good catches, guys. Let's go on to the next one. So these are a couple of the fractiony sort of ones that tend to throw people for a loop because they kind of get caught off guard by which tool to use. So first of all, we're taking a derivative in this one. We have e to the x over x plus e to the x. You kind of have a couple options for how to do this. I kind of figured I was cool with just jumping in with some quotient rule. So bottom d top minus top, those look stupidly similar, over the bottom squared. And it turns out the tops are pretty similar, e to the x minus, and so I just get x e to the x minus e to the x over x plus e to the x squared. And that's probably good enough for that one here. This is an integral involving a quotient of e's. So here I did the quotient rule because I was doing a derivative. Here I'm going to have to do u substitution. And, oh, we got lag again. Feels bad. So I'm going to hang out for a second here and try to wait for it to catch up. Let's check on my client. Oh, I can't do it without losing my stuff. Am I using McDonald's Wi-Fi? No, I actually have like a really sick router. So I am very confused as to why it is struggling right now. We must be having outages in the area. Yeah, I'm going to come back and do this one. Let's check the stream health. Looking okay. Check here. Okay, it looks like we're caught up at the very least. Okay, so on the right one here, I have e to the 3x over e to the 3x plus 3. I make u the bottom. Now I said make u the power a lot of the time, but not here. Although there kind of is some chain rule happening within our u substitution, so we're kind of associating it. So we get du equals 3e to the 3x dx. So this is something a lot of people forget, at least from what I've noticed, when doing their exponentials, is not chain ruling down the stuff in the power. And so I don't get exactly what's on top. I have to divide both sides by 3 to kill this 3 and get exactly what I have on top, which is e to the 3x dx. Now when I rewrite my integral, I get du over u, like I wanted. Du is the stuff on top here. U was this. But I had du over 3, so I need to bring out a 1/3 out in front of my integral. And now what I get is 1/3 times the natural log of e to the 3x plus 3 plus c. And now we're in like a really interesting spot, because where we've gotten is we've gotten a natural log of an e. And a natural log of an e, even in an absolute value, exponentials are still always positive unless we're multiplying them by something negative or subtracting something. So this is just like we get to pull down, we get to just get 1/3 times the absolute value of 3x plus 3 plus c. That's a dope question. Dang, I just wrote that. Sick question. I did skip a step here. 1/3 natural log of the absolute value of u plus c. I just plugged in u right away. If you were curious, or if I lost you there, that's what happened. So that's a cool problem. Now I wanted to go on another problem that I know is cool because I really like this question. Is this bottom one secant to the 4th times tangent of x? This is like a really hidden natural log question. And the way we get unhidden is we logistical problems here. All right, is we Well, let's try something first. Let's try making a u substitution. If I make u equal to a secant or tangent, let's try tangent. Then when I get du, I'm going to get secant squared x dx. And I'm like, crap, I only got secant. And so here's something a lot of people do on quizzes that makes me a sad panda, is they square both sides. Which, you know, technically legit math will kind of legit math. But this doesn't work because we can't integrate something with a du squared in it. This is garbage. So we got to scrap the technique and try again. The desired technique here is to rewrite things in terms of sines and cosines. If you rewrite this in terms of sines and cosines, you get sine of x over cosine to the 5th of x. Because secant is 1 over cosine to the 4th, and tangent is sine of x over cosine of x. And once you get here, the u substitution's a lot more obvious. We can just make u the bottom, like one of our favorite tricks. If I make u equal to cosine of x, du equals negative sine x dx. So if I rewrite my integral in terms of u's and du's, I get the negative, because I don't have this negative in my original, so I have a negative du. Du over u to the 5th. And now people get into trouble here too, because they want to integrate the top to u and the bottom to u to the 6 over 6. But that makes me a sad panda. When you get a u to the 5th on the bottom, you should get a u to the negative 5 on top. And now we just do power rule. Raise the power by 1, divide by the new power. We get u to the negative 4 over negative 4, and it's negative, so these kill each other, plus c. And so if I write my answer, it's just going to be cosine of x to the negative 4 over 4 plus c, or 1/4 secant to the 4th of x. So I was actually talking to some of my friends this weekend. We had like a going away party for one of my friends, and I got talking to a couple of my friends about how awesome integrals are, because they're like puzzles. You have to like pull them apart and keep trying different things until you get to the right answer. And this is one of those first indications of crazy puzzles when it comes to doing integrals, like a really hidden sneaky fraction problem here. Didn't end up needing natural logs, feels good, but you need it for tangent if you're integrating just that, and that sort of thing. So our last one I wanted to look at was one where we have a natural log and we're integrating. We never integrate natural log just by itself unless we have a calculator, like the first free response question I gave you over break. But we can deal with situations like this, because if I make u equal the natural log of x, du equals 1 over x dx, and that accounts for my denominator in this problem, and I can rewrite this integral as just u to the 5th du. So if I can turn it into a power rule function after making a substitution, I've done something correct. That's like calculus 101. I integrate u to the 6 over 6 plus c, and I just plug in natural log again. So I think you had a couple homework problems like this guy. Like one on a worksheet and one in the book. I think I helped some people with ones like this. And I just wanted to throw one of these in here because people were like, I want more integrals with natural logs in them. And this is like the only kind that we know how to do, realistically. Alright, that was a lot of talking. That was all my planned stuff. Sorry about the disaster fiascos during the middle of the free response. Free response are so easy. The ones on the test should be reasonable as long as you're really good at your... I mean, I guarantee you there's going to be exponential natural log crap in there. And so if you're good at that stuff, you should be able to do the free response questions on the test coming up. So yeah, I wanted to open it up to people who are here, since I was kind of doing a lot of the questions of people who aren't here. Does anybody have any questions? Oh, you want to see a review that I'm going to give you on Monday? It's like all this crap. Look at all this. Wow. So we're going to be doing this like in class, this thing. next class. We're just going to take notes on inverse trig, of which there's going to be one question on the test, and I haven't written it yet. Can I do the AP questions 3? I did do AP question 3 at the very beginning of the stream, Andrew. Do you want me to do it again? I'm happy to like do any other kind of question too that's like in here. I put in like smorgasbord review and lots of exponential stuff because if you know exponentials and you can do exponential derivatives and integrals, you're going to be in Fat City for the test. Can I do it again? I can do that again. No Hearthstone? Tim is walking. I was actually doing a dungeon run right before this, just killing time. Got Death Rattle and Battle Cry Priests. It's kind of fun. Dungeon run's a little boring though. I just win most of the time, so eh. That's why Slay the Spire is awesome. Alright, what was I doing? Sorry, distractions. People are talking about video games. That's one of my weaknesses. Bullets, my only weakness. So, kind of a quick-ish overview of 3. The very first question we did after the quizzes today. This one. For the first one, you just took the derivative of this thing, and you had to do du over u, the chain rule thing. And then you just plug in 4 and you get 5/7. For the second one, you're looking for where it changes direction, so you just set the velocity equation equal to 1. Set the velocity equation equal to 0. And the reason why I mentioned 1 there was because where natural log is 1, velocity is 0. So I set the inside of the natural log equal to 1. And just solved this equation and did first derivative test with it. And this factors super easily. T squared minus 3t plus 2 equals 0. T minus 2, t minus 1. Then once I got those values, 1 and 2, I tested between them and outside of on either end to figure out where it was decreasing. It was decreasing in between. If you plug in 1.5, it makes one of the equations negative, makes the other positive. That's where I'm traveling to the left. So this is traveling to the left from 1 to 2. It then says, find the position of the particle. This is the part that throws people for a loop a lot on the AP test and often shows up in free response questions. You have to take your initial position, which they give you, and integrate from that initial position to where you end up in your velocity equation to get the change in position. To get the new position, rather. The integral is the change in position, and the 8 is the initial position. If you add those together, you get where you currently are. And lastly, it says find the average speed. All you do is you take this exact same integral here, you throw absolute values on it, and you divide it by its width. And all of a sudden you found the average speed. And that's it. That's that question. Lots of calculator work I didn't do here. Like I didn't plug in what this is. But that is how you do that one. So many spammers in chat. Anything else math related before Cooper and Tim get way too tilted because I just shut off the stream? Yeah, nothing here either. People are logging off. It seems like we're good. Johanna's good. Anna's like rip stream. Apparently I might be dropping frames again. Feels bad. The test is Wednesday, folks. It's not Friday. Oh, Andrew's just trolling. Classic. Friday we will have a quiz, so those poor basketball people are gonna miss 2 things, and cheerleading. So poor Lauren and Cade and maybe Jack? Not sure if anybody else is affected unless they're like traveling with them, because those people are gone from like Wednesday morning through Saturday night. It's crazy. They're missing so much school. I mean, it'll be fun, but ooh, that's heavy. So yeah, have a good night, y'all. This was a nice short stream. I'll see you tomorrow in class. We'll talk more. I assume so. And yeah, have a good one, y'all.